Hello, everyone. Welcome to this month's Professor Messer Network Plus study group. I'm James Messer, and we are going to go through quite a bit in the study group for this month. I've put together a list of all kinds of questions you've sent me. We have how our chat room is going on one side. I have all the questions you've sent me on the other side. We're going to put it all together and see what we can come up with during this session. So one of the things that I'll start with, let me bring up my view of the world here so we can talk about this, is what we're doing here. This is a monthly study group session. We started this a couple of months ago, and I got such good feedback on it that I thought, let's just do one every month. And you're sending me such great questions that you're really making it so easy to put these things together. So why don't we have this set up to just go through your questions, things you email me, things you talk about in the chat room that's on professormesser.com, things that are in the registrations you send me. I put them all together and we see what we get. So there's quite a bit we'll go through today. If you are interested in seeing our course, that is the downloadable version in high definition. These are the MP3 files you can listen to for audio. I've got PDF documents. I've got versions you can put on mobile devices. You can learn more about those at professormesser.com/download-net plus. So let me start with one of the latest announcements. I'm back in the United States. I was in London last week at the CompTIA event for EMEA, and I'm sorry, I have somebody here. I've just cut their head off on this screen. I'm going to get rid of myself for a moment so you can't see that. Let's see if I do that, if I go away. Maybe not. What we had done during this conference is CompTIA asked me to come over and just do a presentation. I really talked about training and using the internet to do training, primarily social networks and things like this. I think this is a very unique, interesting way to get feedback from you and for me to get things into your hands as well. It's been a very interesting, and it gave me an opportunity to meet a number of people as well. We had a great time at the conference. I got to see a lot of people at the conference and see a lot of people afterwards at a meetup. So we had a really good time with that. I'm hoping to do some more of those. There was some talk of CompTIA having another event in Las Vegas very soon. I'd love to speak at that one as well. We'll see if they'll invite me for that one. And if we are, we'll do another one. We'll go do an event and maybe do another meetup. Assuming there's a pub of some kind in Vegas. I'm not sure if there is or not. Maybe somebody will know. And that's a very easy thing to set up. And it was great to meet you guys when I was over there. I had such a great time. I have to get back there very shortly. What we're going to do in this session is go through all of your questions that you've been sending me. I can't go through all of them because there was a deluge of questions that came in. I say millions were submitted because it certainly seemed that way. There was a lot of questions you guys sent me. And one of the things that we'll step through is as many as I can. And I tend to take the questions and put them into a large group. And then I try to figure out just which one of these questions or groups of these questions can go together. And we usually end up with some type of theme for the monthly study group that we have. And indeed, this group of questions during this month, a similar scenario. So you'll see a theme throughout all of these as we go through. Let's start with some of the content that we get from the exam questions. And I'm going to start with and really focus on protocols and network communication during this particular session. Our first question that came in was from Hermione T. It's not Hermione, you'll notice. It was something a little different. What about IPv6 do I need to know for the exam? Boy, this is a good question because IPv6, of course, is something that has become a lot more popular lately. It's something that was added in the latest Network Plus requirements. It was something that was added even to the A+ requirements back at the beginning of this year. So obviously it has the ear of most people. And indeed, many organizations are starting to deploy IPv6 as their connectivity to the internet, at least on a trial basis. A lot of our service providers are even now providing IPv6 services to our homes if we wanted to do it that way. Comcast has a trial going right now. I believe it's in California. So there is a little bit of information you're going to need to know about IPv6. The Network Plus exam does not go into excruciating details about IPv6, but you do have to understand exactly the way it's laid out and what it looks like. And if we look at some of the latest documents that I have on IPv6, you can see that it was IP protocol version 6, look at the address formats for this. Very large. This is something that is a very different view of addressing than we are so accustomed to with IPv4. And you can see there's, for instance, in this format, there's a lot of information we have to see. Not only are the addresses now in hexadecimal, they are separated in groups of 4 with colons. So this is already a completely different format than the IPv4 stuff left. And you can see, for instance, if we wrote out the entire format, this is 128 bits or 16 bytes long. That's a long address. And that's for a reason. We want to have these big addresses so that we're never going to be in a situation where we run out of IP addresses again. This is a very useful thing. One of the things you'll probably want to know for your Network Plus exam is not just this format and how it's laid out and what it looks like, but you may also be asked about the shortcuts that you can do with IPv6. And let's step through one of these so you can see this. In this format, I'm going to take one particular address that's here, and let's look at this address. There's an IPv6 address on the screen. This is FE80, 000, et cetera, et cetera, et cetera. It goes all the way down the line, all 128 bits of it, they're represented in a hexadecimal format. Now, what we want to be able to do is look at this and try to maybe put it in a shorter format. Because this is so long, when we created this IPv6, we also created some ways to make shortcuts of these things so we would not have to write out all of these addresses every single time. So what we want to do is look to see places where we might have leading zeros, because it would be perfectly appropriate to write the address like this, FE80, and then you can see the rest of it there. In fact, we got a couple of zeros gone in front of that A7 that's right there. So that's already an opportunity that we have to make these a little bit smaller, but we can even go a lot further than that. Well, let's take and also take any time we see 2 or more groups of zeros that are right next to each other, those 4 zeros in a row that are right next to each other. So they have to be contiguous. They have to be connected to each other. We could actually replace them with double colons. So this is the exact same format, all now laid out with the double colons on it. And finally, if you wanted to see the final version, that's what it is. So you can take this entire big address that's right here at the top, and then you can see what it turns out to be once you shorten it down. So even though we see these really long IPv6 addresses, most of the time you will see them shortened. In fact, you'll almost always see the leading zeros are gone. You will occasionally see an address that's very common to see a double colon. Now, you can only use the double colon once. So if there are multiple sections where there are zeros, you have to pick one of them. You can't do it twice within the same address. But you can see a lot shorter. So at least it's a little bit better. If we're trying to struggle with working with IPv6, that's at least one thing we can count on, is making those addresses a little bit shorter and a little bit easier to work with. The addressing is one thing, and knowing what we're looking for in IPv6 is one thing, but I also got a lot of questions about fundamentals in networking technologies. And some of this has been a problem that we've created for ourselves. The question that came in from Jose is, what are the differences between a switch and a router? And there needs to be some type of delineation here. Those are two different things, but unfortunately, we very often have them all in one device. In fact, if you have a home router plugged into your network connection, and you might have a wireless connection on that as well, so you can feed wireless throughout your facility, it's plugging right into that network link, you probably both have a router and a switch all in the same device. And so it's one box. You can't even tell that there's any difference between the router and the switch. You aren't exactly sure where one stops and where one ends, but they are doing different things inside of this box. So I think it's nice for us to be able to step through what these differences really are. And what I'm going to do is go way back. This is, this is an old token ring bridge that I used to work with. Way back in the day, all we had was these bridges. We would plug our token ring into them. And this bridge was really focused on connecting either identical network types or even different physical networks. We would connect up, for instance, a token ring network and an Ethernet network to each other. And I think this actual bridge that's here is one that does exactly that. Now, what's interesting about this is that it all operated at layer 2. Now, if we look at our OSI layers, and we're going to do some of this in just a bit, we think about layer 2 of the OSI layer, I'm really talking about MAC addresses. When you hear anybody say we're looking at layer 2, you should immediately think bridging and switching and MAC addresses. That's, if you remember nothing else of layer 2, remember that. That will get you through. So that's how these bridges worked. They knew all the MAC addresses, all the physical addresses of devices on one side of the bridge, and we looked at all of the physical addresses on the other side of the bridge. And that bridge was responsible for sending traffic back and forth, depending on what the destination MAC address was of that device. Now, what's interesting about this, you'll notice this is a big old box. It's like 3U high or 4U high. Those are units, we call them. And that looks to be about 3U high. It goes in the rack, takes up a lot of room. Do you see how many networks would connect to this? 1, 2. 2 networks. This is a 2-port switch, if you will. It's one big bridge that only connects 2 networks. That does not scale very well, but back in the day, that's all you can really do. What we ended up doing, though, is making these much smarter switches through this. So these are exactly the same functionalities as the bridge we were just looking at. It determines where traffic is going based on its layer 2, its MAC address. But look at all the ports on the front of it. It's got tons of ports on the front of it. I can plug in all kinds of connections and they can all talk to each other directly. They don't have to go through another device. They don't have to talk through another system. They can all communicate to each other, and you can have a big stream of traffic going between 2 devices over here. Another 2 devices on the other side may be talking. Neither of them knows any of the others is taking place. There's tons of bandwidth. There's a lot going on there. This is all done. We're all able to do this because we have these ASICs that are these application-specific integrated circuits, that their job is to bridge this traffic. Their job is to switch this traffic. So that's one of the nice things that's there is you're able to plug in all of these devices now and communicate with this switch, recognizing where all the different MAC addresses are. And obviously it's doing a lot of work. It has these big tables just full of MAC addresses. So when a packet comes in, it looks at that MAC address destination and says, I wonder where that guy is. Let me look through my enormous list of MAC addresses. Oh, you're on slot 4, port 10. I'm going to send it out that direction. So there's a lot happening here, but it's that port density that really makes the difference with these switches. But at the end of the day, it's just a bridge. It's just a layer 2 device that's determining where to forward traffic based on the MAC address, all at layer 2. That's a switch. Now, one of the things you'll see also, and this is probably something you have at home, is wireless access point. But when you see the word wireless access point or WAP, it's not a router. This is also a bridge. This is also a switch. So already we've looked at 3 separate devices that are all working exactly the same way. They're looking at the MAC address and they're sending it on its way. They're looking at the layer 2 address and figuring out where the traffic is supposed to go. Now, if it's something like this, you've probably even seen a device like this before. You might even have one at home or in another network. You've got to look at the front of this device to determine, is that a switch? Is it a WAP? Or is it a router? It might have routing capabilities within it as well. They look exactly the same from the outside. You have to look at the details that are written on the device or log into the device in the configuration side and see exactly what it's doing in there. But keep that in mind. That may not be a router. Don't assume that when you're walking in, oh, he's got a wireless router. Don't make that mistake, because you have to troubleshoot and figure out what's going on, and you've incorrectly identified that as a router when in reality, it's merely switching. And if you're trying to figure out why you can't talk to the internet, and then you realize, I don't have a router. I thought that was my router. Nope, I'm going to need another piece of equipment to get in here to connect us up and route out to the internet. And that's, of course, where routers come in. Here's a big router, kind of an older router, but router nonetheless. Routers don't care so much about the incoming MAC addresses of what's coming in. They care about the layer 3 address. They determine where traffic goes based on the IP address. So you might have switches all around in the background, switching and sending traffic back and forth. And ultimately, somebody may need to go to the internet and it hits this router. And the router says, oh, you need to talk to Google? Let me send out this based on the IP address of what Google happens to be, and I'll send it on its way. This is layer 3. So when you're thinking about switching, it's layer 2. You're thinking about bridging, it's layer 2. You're thinking about WAPs, it's layer 2. Routers are at layer 3. And when you're trying to figure out how this all works together with your OSI model, that's a very good delineation of this. The only time this really gets to be a challenge, and it's not really going to be the biggest problem for you on your Network Plus exam, but in that real world scenario, the problem you may run into, I'm going to go back a couple of slides, is that this switch may also have a blade or a function inside of it that also routes. So it's very common to see devices like this that can switch between a bunch of other ports, but you could also program it to route between other ports. It gets a little more complicated that way, and that's why we're getting these Network Plus certifications, of course, is you want to be able to understand the differences between those two and be able to manage it should you happen to run into those scenarios. But as long as in your mind you keep those two functions completely separated, you set the switching over here and you set the routing over here, and you think of it that way, you'll be just fine. And in reality, the switch itself doesn't combine those things when you're configuring it. There's generally a completely different configuration section for the router and a completely different configuration section for the switch. That makes it easier. So one of the things that was asked in the chat room, in fact, was if a router works with IP addresses, which we know that it does, it's layer 3, then how can I block a system using its MAC address? And a router would not be the place to do that. That MAC addresses themselves are not very good ways to block traffic because MAC addresses are only known on your local subnet. So if somebody from a third-party site somewhere is sending traffic to you and maybe causing a denial of service, you have to block it based on its IP address. The MAC addresses are different every time it stops through a new subnet. So if you're receiving traffic from your upstream ISP and it's sending a bunch of different information from you from all over the internet, all that traffic is coming from the same MAC address, your upstream router. But there are many, many different IP addresses associated with that traffic because they're coming from all over the internet. So if you're looking to block traffic, you would want to do it by IP address in a large environment. If you're in a very small environment where there's only one subnet, well, you could probably get away with blocking based on MAC address there, but it's not something that scales very well from that scenario. Another question that came in was, the Hawkster13 says, what cable should be used when connecting two switches to each other? I'm going to back up so we can see these switches, a picture of this switch that's here. It's very common in very large enterprises to have many, many switches, hundreds of switches that are in different buildings, that are in different cities, that are all in a single data center. And you want to have these devices talk to each other. It's very, very common then to need some type of high bandwidth connectivity between these switches. And this switch that we have on the screen, you can almost see there's a couple of ports at the beginning. I don't have a pointer to show this, but there's a couple of ports at the beginning of some of these blades that are fiber connectors. They're fiber ports. And that's generally what you would use to connect these devices together, because generally you're going over long distances between switches, or you want to be sure that you're able to connect them over a medium that would not be subjective to any type of interference from radio transmissions, for instance. So it's a very clean way to connect, and you can connect over long distances, and fiber can generally support large and high speed type connections. And if you're connecting this many ports to another switch with that many ports on it, you're going to need a lot of bandwidth between. Sometimes you do more than just a single connection. Maybe you put multiple links between those switches and make it go faster. And that's a very, very common way to see that working in those environments. So that's your summary of the routers and the switches and the bridging and the WAPs. And this is something that you may not get right off the bat. It may not be something that's instantly you recognize how it's working. But if you start looking at the traffic, maybe grab a copy of Wireshark, start capturing traffic that's coming from your router. And you'll notice you're seeing all this traffic from Google and from ESPN and the Professor Messer website and from Ustream. You're seeing it all come in, and you notice the MAC address is always exactly the same. Then it may start fitting together for you, and you see that's the MAC address of my router. And it's also a different IP address because one is a layer 2 address and one is a layer 3 address. And that's how they all interoperate and work together. It's a very, very sleek system that we've put together so that we're able to communicate with this digital modes over very, very long distances. And it's one that once we understand exactly where we're trying to troubleshoot, whether it's a switching problem or routing problem, you'll be that much farther ahead of solving that issue. Another question that came up, since we're talking layer 2 and layer 3 and going through that mess, now we're dealing with all 7 layers of the OSI model. Does every network follow the OSI model? Oh, that's a good question. So think about that. Does every network follow the OSI model? And I would say yes, and I would say no, because the OSI model is a model. It's something that we use as human beings to try to understand an underlying communication method that's occurring across a network. And what we've tended to do is to put different functionality of that communication method and fit it into these different layers. So yes, absolutely, we can fit everything into all 7 layers of the OSI model. Just keep in mind that it's a model. And it's something that you can think about, and it's an idea of how it is working. This is not something that is solidified in stone. You can have arguments on whether something is at layer 2 or layer 3 or blended between those layers. Those conversations can actually occur. So, but if you were to take the real world and fit them into different OSI layers, what would they look like? And here's a really good example. So on the left side of the screen, I have the OSI model. We've got physical data link network, transport, session, presentation, and application. And if we start from the top bottom, all people seem to need data processing. You probably have your own terms that you use to help remember the OSI model and how it works. But let's start at the bottom. The physical layer of the OSI model we tend to think of as something like a network adapter, a network card, a cable, a physical connection. And that is indeed the physical layer, so that makes sense. We were just talking about switching being at layer 2, so that's exactly what you would find at layer 2. MAC addresses, you could look at the different MACs and the switch type configurations and bridging. That all happens at layer 2. If we need to route outside of our network, we go up to layer 3 because we're talking about IP addresses and routing, and we're sending these packets out over those routed configurations. Now, if we look at this and really break down layer 4, now we're starting to put data inside of these packets that we're sending back and forth. And so we can have TCP data, you can have UDP data in there, and you've also got things like being able to control protocols and see what's happening there as well. This is one of those things where now we're blending in even more data within the packets that we're sending out. Generally, 5, 6, and 7 almost tend to be blended together. We almost tend to have a look and see, for instance, I'm going to move off to my connections to view that and see exactly what that looks like. I think that whenever I'm looking at the OSI model, I tend to always lump 5, 6, and 7 together that way. It's very common to see that, in fact, because the tunneling protocols, the encryption, and your eyes, the way the application is being presented to you, is all in those top 3 layers of the OSI model. And that's one of the nice things that we see whenever we're looking at real world and OSI model is we tend to put things at each one of those categories. If you were to look at, for instance, I mentioned grabbing a Wireshark decode of this and being able to see it, you can get an idea of how all of those different models tends to work there. And this is one of those things that I work with, and I can see MAC addresses, I can see IP addresses, I can look and see all of those different pieces associated with it. And if you were on, for instance, Google Mail, you can map all of those things to the OSI model right up to Google. For instance, at layer 1 is your electrical signals. You're on an Ethernet network at layer 2. You're encapsulating things within an IP packet so you can route it out to Google there at layer 3. Layer 4, you're putting TCP into that IP packet. And layer 5 and 6, you're looking at taking the data and encrypting it up and finally having the application show up at Google and reversing the process when it comes back to you. It all happens over and over and over again. So that's one of those things that I run into very often is how can I take that idea of OSI and apply it back to the real world? Well, there's a really good example right there of exactly how you could do that. And staying with that theme of OSI, one of the questions I got from Steve C was, hey, is that OSI 7 layer really only 4 layers now? What is that? I saw a 4-layer model. Is that the OSI model? Was that something different? And indeed, this particular question comes up quite a bit because there's something called the TCPIP model. This model is a little bit different in that it only has 4 layers associated with it. And for your Network Plus exam, you need to know both of these. You need to know both the OSI model and you need to understand the IP model as well. When we're talking about the IP model, we're usually referring to this as the Internet Protocol Suite. It's very similar to the OSI model, but it really fits a lot of the IP protocols right there within it. And if you were trying to look at how the real world works, this is a very good example of how that all gets applied. So there's 4 layers we have to deal with: the application layer, the transport layer, the internet layer, and the link layer. And it's very easy to draw out, for instance, exactly the way the traffic flows. As it's going from router to router, it only has to go up to the internet layer. Only at the endpoints do you ever have to go up into the application layer to see what's going on. So it's one of the nice parts about visualizing this. It's very simple to see how that would lay out. And perhaps even easier, we can see exactly which protocols happen to fit into each one of these. So if you were trying to figure out where does TCP fit into the IP model, there's a very good example of that. If you wanted to see how the link layer works, there's a good example of how you might do that as well. So there's some very good ways to go about looking at some of those things and how they operate. And you need to know both of those models if you're planning to go out to the network and sit through and understand more details of exactly how these things are working. So keep in mind that you need to know the OSI model, you need to know the IP model, but also keep in mind that you don't have to know excruciating details about these. These are literally 2 different sections on the entire Network Plus certification set of exam requirements. So don't spend a lot of time trying to memorize exactly details about every single piece. You just need to know the basics. In fact, that overview I just gave you is probably all you would really need to know about understanding how this works in the real world. For your exam, they're going to ask you some very specific questions about the model and the different layers, but you're not going to need to know how to troubleshoot or how to take an entire traffic flow like I just did and put it into every layer of the model. It's something that a nice overview should really work just fine for you. One of the other questions that I got is this one, and this one's pretty interesting. So this question is, I heard that SSL TLS has been recently cracked. Oh, that's an interesting one. Will switching to IPv6 make the internet more secure? That came from James W. Now, that's interesting in itself, because whenever we think about encrypting our traffic to buy things online, we want to look at our healthcare information, we want to do online banking. And one of the things that is very important to allow that is SSL, or what is probably more properly called TLS. The SSL encryption that we're talking about here, and the reference to this being cracked, goes back to some researchers who found a way to do a man-in-the-middle attack against SSL on somebody's workstation using JavaScript. Now, it also required that the person in the middle be on the local subnet, and you also needed to be able to set up the man in the middle and be able to retrieve some of that information. There's a lot of ifs that have to occur. So today, this is more of a research project that they showed a proof of concept of how you could get into the middle and quote unquote crack this SSL encryption. But the reality is the methodology they use to do this is very common. It's used all the time in corporate environments to be able to break open SSL and see what's inside of it to protect their own servers. They just found a way to do it on a single workstation. And ideally, the proof of concept would be one where you would not know that this particular one was occurring. So the question of that being SSL being cracked is not entirely the case, but of course we should always be wary of how our encrypted data is being used and where it might be going. But the other question here was probably more interesting to look at. Will switching to IPv6 make the internet more secure? Well, I don't think that a single switching to IPv6 will make it secure, but you should know that within IPv6, encryption is something that is built into the protocol. We've already got functionality there to build tunnels and to encrypt traffic from one end to the other. We knew when we were creating IPv6, there was an opportunity there to build in IPsec or IP security right into the protocol itself. So that is one of the advantages of IPv6, is not just that there are a lot more addresses to go around, but a lot more functionality in the overall makeup of the protocol, especially as it relates to doing things like encryption in IPv6. At this point, I want to talk to you a little bit about the sponsors of this particular study group. This is GTS Learning, and they're an organization I've been working with for a while. that they create their own study guides. As you know, you've probably been watching my videos on the internet, the videos that I make absolutely free, and I had to start making them from scratch and building out all this content myself. It takes a lot of time to put together just one video. And one of the things that was nice with GTS is we talked to each other and realized, I've got videos, you've got books. Why don't I use your content, build these videos out, and then we can just package them all up together, and even in some cases, integrate the videos inside of the book itself. That's amazing, and to see this actually working. We've put these QR codes right in the books. So if you're reading along and you're seeing something in a book that interests you, you can scan the QR code with your mobile device, or if you're looking at it online, simply click the QR code. There's a link built into that, and it will open up my video in YouTube. So it makes it very simple to integrate these videos within the books. Our Security Plus book is doing that right now. But they have great materials. And if you'd like to download a sample of what they have, these are books that have been approved by CompTIA. They've handed them to CompTIA and said, is this going to work? And CompTIA has given them the big check mark. They are a CompTIA authorized partner. And you can download a sample copy yourself from professormesser.com/network+book. And see for yourself if this isn't the type of book that might help you get through some of your Network Plus certifications. We appreciate having them as a sponsor for these study groups. It allows us to do this every month. Whenever I start looking through these questions every week, some of the things that come through are questions not about technical topics, but questions about the test itself. And I think in some cases, those are just as important as some of the technical things that we might look at. So one of the questions I got both in, if you watched the A+ study group earlier today, but I got it here as well, is can I pass the exam without any hands-on experience? And for the A+ exam, I said, you know, it's very hard to pass the A+ exam without hands-on because there's so much hardware and installing drives and installing CPUs and fans and understanding the cooling. There's a lot of physical pieces to that. Network Plus, though, is probably a little bit easier to pass without doing any hands-on experience. However, you will really need, it will certainly help you if you grab packet captures, if you understand and see where your packets are coming from a router, if you do the troubleshooting of your network connections at the command line, so you're using traceroute and pings, those types of things, that will gain you much help when you're doing your studying. Although I've had people say, well, I've just watched your videos and I've taken the tests and I passed. It was great. People are doing that, but I certainly don't recommend it. Get a great book, watch my videos, perhaps get some Q&A guides, and do some hands-on. It really doesn't take that long to do, and I think it really solidifies in your mind exactly the type of topics that you're going to need to know. Let's look at this for a moment. I'm going to step through this next question because this one's pretty extensive, and it comes to us. I got many questions about this. Let's flip over to this. Could you review the new exam objectives? So at this point, this is from Joe M. At this point, I think it'd be good to take a step back. So what are these new exam objectives? If you've been out to the CompTIA website to download the latest exam objectives, and if you're looking for those, just Google CompTIA exam objectives, you'll find that there are two sets there for Network Plus. One that's for the 2009 series, and then another one that's brand new. The N10005. If you remember, N10004 is the current one. You could go out and take this test right now. Now, since they have posted a new set of requirements, and it's been there for a couple of months now, that new set of requirements almost certainly means that we're about to have this new release. And CompTIA has not officially said this yet, but that's generally the way they do this. And what we're expecting is that when they release this new version, there will be an overlap where you can take both exams at the same time. That way you don't waste any time with your studying. But since they released the new objectives, there's an opportunity for us to now step through the new objectives. Is there anything new? Is there anything notable? If I want to plan to take the new exam, what are some of the topics that I need to prepare for? So what I did was take both of these exams and I looked at both of them side by side. And then what I'll do for you right now is break out for you the big differences between these two exams. So N10004 and N10005. On the top here is N10004. There were 6 domains, and you can see the percentage associated with knowing what's in those domains. Notice now we only have 5 domains. Really changed quite a bit. So a lot of these things like network technologies were now built into other domains in the N10005. The content was generally kept the same between both. There were a number of things added. Not much was removed. There was really more things added than what was removed. Some things were updated. Some older concepts were perhaps phased out. But for the most part, you have exactly the same information in 004. You've just got a little bit more that's now been added on in 005. So let's step through what's new and what might have changed between those two. We'll go domain by domain by domain. So in the first domain of N10005 networking concepts, here's an entirely new section that you need to know. So this is a lot of new content, and this is all on virtual network components. And this is incredibly important, of course, because anywhere you look today, any large organization, any small organization is now loading up these brand new virtual servers. They're no longer putting separate devices in the data center that all have a single task. Everything is now running on one physical box, and inside that physical box may be 20, 50, 100 different servers inside of it. And because of that, you're going to need how to network all these things together. You're going to need to understand virtual switches and virtual routers and virtual firewalls, and you'll need to understand how they interoperate with virtual servers and PBXs and all of those things. So as we start getting into more of this, and looking at the N10005 requirements, that becomes an entirely new section of the exam you're going to need to know about. And that's incredibly important. It's becoming even harder now to find any organization that isn't doing some level of virtualization. And you can imagine a virtual environment and the networking is a little bit more complex than the traditional physical environment and the networking that goes on there. So another important section to consider for your N10005 when we finally get the announcement that that's available. The next section that we'll look at there is section 2. It's the second domain, which is the network installation and configuration. There were 3 different sections here inside of this domain that were added. One was, given a scenario, install and configure routers and switches. This wasn't even mentioned very much in the existing 004. So they really broke out and wanted you to know comprehensively, how do you install and configure a router? How do you install and configure a switch? Another section in here was, given a scenario, install and configure a wireless network. This is also a big departure from the existing 004, because the existing 004 requirement says you need to understand a basic wireless network. Well, now in the latest Network Plus, you need to know everything there is to know about wireless networks. The basic doesn't work anymore. Every organization has wireless, so therefore we're really, really going to need to know exactly how this wireless network might work. And section 2.3 inside of domain 2, explain the purpose and properties of DHCP, brand new topic. We're going to need to drive that and drill down into DHCP and understand the leasing process, understand the renewal process, understand how to set up different options within DHCP. The next section that I wanted to look at was section 5. I kind of skipped over 4, didn't I? Here's 4 right here. So here's section 4. So given a scenario, use the appropriate, or maybe that's section 3. It is section 3. I just have 5 at the top. So section 3 is categorize WAN technology types and properties. There were a lot of updates to the WAN section. So a lot of the older DSL, VDSL, and other multiple DSL things we had to remember have now been updated. Now you just need to know DSL, and they updated the wide area network technologies around that. There wasn't much of a change, though, on the LAN technologies. And a lot of you say, how can I remember all of these Ethernet technologies that are coming through? Well, that's a really good question. You just have to memorize them. And that does not change in N10005. So all of that effort that you're going into to take and memorize all of those different Ethernet topologies, you have to know in the new version as well. Nothing changes there. Sorry about that. So the section 4, the domain 4, is network management. And there was a lot added here for network monitoring, an entire section just on network monitoring. It goes into capturing packets. It goes into doing in-map scans, Nessus scans. There is actually, the Nessus is the next section, but it goes into syslog. There are a lot of new topics here that are not on the existing 004. So more new content that you will need to know. The scanning capabilities for Nessus and Nmap are right here in section 5 under network security. You need to install and configure a basic firewall. That's a brand new one that you're going to need to know. And the 5.6 is categorize network security appliances, IPS, IDS, vulnerability scanners, and how you might use some of those scanners to secure your networks in your organization. So there you go. There's the summary of what's coming. Now, we aren't exactly sure when N10005 will take effect, but it's already been out for a couple of months sitting there on the website. I would expect any day now, next month, the month after, somewhere, we're going to get an announcement that tells us exactly when that is going to be available. So I expect that to be very shortly. I'm not a CompTIA member. I'm not part of CompTIA. I don't have any insight into what's going on there. I prefer to be independent. So I know when you know. So if you see it and I haven't talked about it, let me know. Send me an email. Send me a tweet. Let me know that they put something new out there, because I'll just keep checking. And if you see it before I do, please let me know. And this leads us into this next question is, will there be more videos added to Network Plus? Well, there will not be new videos added to the existing Network Plus, but one of the things that obviously has to be updated now is all of the Network Plus videos for the N10005. So I'm already working along those lines. Obviously, it's been out a couple of months. There's production work already underway, along with a bunch of other things we're working on here. But absolutely, we will have the N10005 videos out. And as soon as I am making them, as soon as it's released, we'll put a big chunk that we've already got ready to go. And then we'll, of course, keep developing them, keep producing them. And as we make the new ones, we put them right out on the internet and see what's there. So that's a very common thing. One of the questions in the chat room is about how the switchover happens. And usually when they release a new version of the exam, there's a time, an overlapping time, where you can take both exams. You could take the new one or you could take the old one. Now, the real interesting part of this is, which is better to take? Should I take the old one or should I study and take the new one? Well, the end game, of course, is that you get your Network Plus certification. And when you get your certification, it's not going to say you took the old one or you took the new one. It's just going to say Network Plus. So it doesn't matter from a certification perspective which one you take and which one you pass. And of course, if you want to keep your Network Plus, you still have to either take continuing education units, collect those so that you can renew it at the end of 3 years, or take a higher level exam that will automatically renew it. So you have to keep it up to date. Eventually, you will have to keep and know the information that's on the new exam, because you'll have to know and update to keep your certification at all. So in that regard, perhaps it doesn't matter so much which version you take. So don't delay yourself. If you're planning to take the exam, just take the 004 exam. If you really, really do want to study the new stuff, study up and take the 005. Just know that when you receive your certificate from CompTIA, it will look exactly the same regardless of which exam you happen to take. The link of the moment this week is one I thought I'd slide in something that was very, very security focused, because we're getting more into security, but I also wanted to blend this in with the networking piece. And this is something I use all the time from Gibson Research Corporation at grc.com. It's kind of a crazy URL. So you may want to Google this. Just Google Shields Up or get to Shields Up from the grc.com website. What this effectively does is scans your internet connection and tells you if anything in that internet connection into your facility can be used to connect or gather information about what's here. So you can check your firewall configurations, you can check your packet filters, you can see how well your firewall is working, and you can see, of course, if somebody happens to not have something configured properly, or perhaps might have some port forwarding enabled that maybe they shouldn't have. And you can see that all here. And in the Shields Up, it runs the scan automatically, and it will tell you right away, oops, I failed. Tells you right there that there were things open and available on your system that perhaps the Shields Up thought should not be available. It should not be able to see that. So it's a good sanity check. If you've just configured a router, you've just configured a firewall, that's one very good way to have a remote automated process scan your machine, scan you to see just how much it's going to be able to see. That's a very, very useful thing. Now, of course, this study group is also something you can use for your continuing education unit. So make sure you make a note of that as well. And you can always follow us and see what's going on. If you were following us a couple of weeks ago, you would have seen that I was in London. We had a great time. I want to thank everybody there again for your hospitality, to keep track of what's going on, to see when the next study group's going to occur, to see what's happening here at Professor Messer. You can follow us on Facebook at professormesser.com/Facebook. You can follow us on Twitter at professormesser.com/Twitter, and on Google Plus at professormesser.com/Google Plus. I just started my Google Plus page. So if you're on Google Plus add me to your circle. Let me see that you're out there. Perhaps that would be a good place to start putting my A+ daily pop quizzes. And I get a lot of you telling me we need pop quizzes for Network Plus as well. So we're considering that. It's all about how much time we happen to have available to build those things. And that's a really nice thing that we're working on. Also want to, again, thank our sponsors, GTS Learning, for allowing us to have this study session today and helping me get the information and the hardware that I needed to get this thing going. And of course, thanks to all of you. You send me great questions every month. You make this so easy for us to put together. When I announce the one for next month, make sure you come in and sign up and put your questions in that one as well. I think it just makes a better presentation for everyone to be able to see. I want to thank everybody for joining us on this month's study group. We'll do another one next month. Keep checking professormesser.com/calendar and all of those other locations to see where that is. Thanks for joining us again. Life is short. Make sure you study well, and we'll see you next month for the Network Plus study group.